welcome everyone. Thank you for attending. As I've said before, please turn off your webcams and microphones. It just tends to interfere and slow things down. We're recording this so that we can edit it down later and put it on our YouTube channel. That'll probably be next week. So I'm John Ellis, Operations Director for the institution, and today I'm pleased to introduce Toby Mottram, and he's here to talk about the issues in designing automated tractors, and we'll go back into that in a minute. Like myself and Paul Linham, Toby comes from a farming background, and we know a lot about the issues that are involved in farming. Farming generally has been, was a backwater of IT. If you've ever been to a farm, they're muddy, dirty, and definitely not where you want your computers. But back in the 1980s and 90s, you might remember the mad cow disease, and from that came a lot of tagging of almost every animal on the farm, but in particular the cows, and they were tagged and computerized, and then farmers started to realize you could use that technology to monitor what milk a cow was giving, you were feeding it, and gradually that's become more and more to optimize how the cows are milked, etc. And this has led even to more technology, to which today Toby's going to talk about. And well, I think at that point I will just hand over to Toby and let him explain.
Well, thank you very much for the introduction, which you've already covered some of my little things I was going to mention. What I want to talk about is basically the introduction of digital agriculture, and I'll introduce myself. And I've got a history in digital agriculture from almost its inception. A little bit about the market that we have in agricultural software and some of the issues that raises up. Then I'm going to talk about what's a tractor and how it's changing, and then what's an autonomous vehicle, which of course we have lots of hype from various places, but no one's actually got one yet. There's a maintenance problem in software, which is very specifically some farm problems. And then we get into some of the more, what you might call the soft issues, but they're actually very current, about who owns the data, who has access to it, and does it mean that you don't own your machine if you have a software license and it won't work without it? And then obviously we can discuss as much as you like. So I shall now move to the next slide, if I can find the button. Right, who am I? Well, I'm an engineer. I graduated from the Open University back in the 1980s. There's a picture that was on the front page of the West Somerset Free Press, because they were so surprised that a cowman could study engineering. And then, by mostly good luck, obviously you get luckier the more you practice, I was recruited to help run robot milking, the project that was starting in the 1980s, run by Mike Street, a brilliant engineer. And there's a little sketch on the left, which is what I sketched out what a robot milker might look like. And I was pleased 20 years later, or more than 20, nearly 30 years later, when De Laval, who commercialized our robot, were using it in their presentation as an introduction. This is where it started in 1989. After the robot, because I'd milked cows for so long, I knew that what you did mostly in a milking parlour, apart from the obvious washing them and all that stuff, you're looking out for health issues, and that's still very much a qualitative issue. You look, you feel, you see what something looks like, and you still see it in vet training, which annoys me because there's megabytes of data behind each cow these days, and they never even mention that in their training. But I invented a thing called rumen telemetry, which I'll mention, and inline hormone testing. And I sold my companies, eCow and Milkalyzer, in 2020, 2021. To be quite honest, I was a bit bored with working in cows, and I've moved on into robots. And I bought a very small plot of land near Exeter, which I've called Robot Haze, because I've got one robot on it, and I'll very soon have a second. And I do a bit of community agriculture by renting out allotments, but mostly it's for me to have a field to play in with a robot. So just to go back to the early days, in those days, I wrote the control software to get the cow in and out of the milking parlour, which was basically on an MS-DOS desktop machine with lots of wires and some gate sensors and some strain gauges to measure the milk flow. Mike Street and his guys worked on a much faster Motorola platform to do the robot arm control, and we used to measure where the cow was in the station by an LVDT. So it was all very analog, and but it worked, and we sold that on to De Laval, and they went away and commercialized it from about 1997. So one of the things to be worth remembering is that it takes, in effect, 10 years to get a complex product from an idea to market. And even now, 25, 30 years on since they launched it, there's still only about 10% of the cows in the world are being milked by robot. The rest are still in very conventional systems, and there's still millions milked by hand. So, you know, the penetration is coming, and it's a big market, but it takes a while for farmers to change sometimes. Then I moved into cow health monitoring, and I was actually rung up in the late 90s by a well-known company called Pfizer, who are not in agriculture anymore, but they had some new product that was going to change the pH of the cow, because for years the vets had been saying, oh, the pH in the stomach, it's low and the cows are ill and it's all less problem, blah, blah, blah. So we built we've got a little wireless IC. In those days, it was pretty large, actually. It was about 30 millimeters across. But we managed to get that down a cow's throat. Later on, we got much smaller ones. And this batch you can see is actually the last batch that I made in 2021 before I sold the company. And yeah, so that then transmitted at 433 megahertz with a very simple protocol. We had a USB receiver, which we started off with a laptop, and then somewhere around about 2007, you thought, hold on a second, we can do this on a phone. So there was a lot of Java coding. And so one of my student helpers there was actually downloading data off a cow, and that's how it worked. But it was always going to be a research organization thing, because actually what we proved very quickly was that the rumen pH, it goes up and down like a yo-yo depending on what the cow's being fed. And yes, you can affect it by feeding, but almost all of it was down to the humans involved in feeding the cows, not in the actual formulation of the rations. That was pretty well organized. Further health monitoring, I'll skip a few bits, but I set up a company in 2016 called Milkalyzer, because for years we've been wanting to monitor the hormones in milk, and because that's the governing thing on cow cycles, the jumping on cow thing, you know, the behavioral stuff, that doesn't get you 100%, but measuring progesterone in milk will get you 100% of the ovulations, and you can time your inseminations perfectly, and it's way more natural than what the Americans call the process, where they bung lots of hormones into cows to get them to ovulate when they want them to. So it's a much more natural system. And here's a picture from 2018, I guess. This was on a gear robot. The white box contains, now, when I was raising money for this business, I'd be going around to tell people there's this thing called a lateral flow test, and they're really cheap to make, and you can measure anything you want with them if you've got an antibody to it. And they all just, yeah, okay, one day. Of course, everybody knows about automated lateral flow tests. Or no, sorry, we know about lateral flow tests, but what really annoyed me was we've just sold a company with a box which will take a sample, pop it onto a lateral flow, wait a couple of minutes, take a picture with a Raspberry Pi camera, and come back as to whether it's positive or negative. And there's me at airports. I'll give a sample. Oh, and then they take it around to a guy in a room next door, and then he looks at it and he thinks, and he comes back and says positive or negative. And you think, we did all that in a box. What's the matter with the world? Anyway, that's one of the frustrations of being an engineer. And in those days, we used a Raspberry Pi, and I realized that the company who bought us out, Lely Robots, who one of the market leaders in robot milking, their head of development said, "Oh, I like it, but I don't want to use a toy computer." And I thought, oh God, here we go. And of course, everything had to then be translated into a Windows-based system, and they put in a much more expensive camera, and then said, "Oh, it's not cost effective." So big companies don't always know as much as those at the front end know. Okay, so that's my whinges out of the way. Let's talk about the markets for agricultural software. Well, obviously, government has software for, and has had for a long time, because they have to give out money and they need to record things, and also obviously big tech companies and supply chains. To be quite honest, I know nothing about that side, but I'm sure that there's all the usual large company issues involved, and legacy software and all the rest of it. So let's talk about farm accounting. Now, the first piece of software that I saw on the farm was bought by my boss back in 1981 or 2, which was Farm Plan, which was an accounting software, and it was based on sales receipts and invoices. And it had kind of struggled because there's still many cash transactions in farming, and you know, you'll often go to some sort of meet of farmers and there's a deal to be done, and they'll whip out a wallet full of £20 notes rather than do it through the books. So that's one of the issues in farm accounting, but that stuff is now pretty well understood, and there's half a dozen companies have that market well stitched up. What used to be frustrating though is the farm accounting never linked much to the farm management software, which in those days, in the early 80s, I was milking cows in Somerset and as a herd manager, and we used to record everything on paper sheets, and I'd go down to the office and then type it all in, and then we could work out cow milk yields and so forth. Now, and in fact, in the late 80s already, in fact, my master's project at Silso was to measure the milk yield of individual goats. Actually, it was a little strain gauge system I set up. And even more amazing well, it wasn't that amazing, but my supervisors gave me a nice distinction, because I was doing it from 60 miles away over a dial-up link, and I was showing, yeah, you can measure things from a distance on a farm. Now, of course, it's routine, and we also have things like weigh cells on machines that'll measure the amount of grain coming off a combine, and the trailers can be driven over a load cell, and everything can be barcoded. So it's a lot easier now to trace many things, mostly on the commodity product side though. What's still hard to measure are things like the bulk animal feed that each cow is eating, for example, which is a major cost to the farmer. There are people I know now working on using image processing to look at how much the cow has got in front of her and how much she eats, but there's still a lot of processing to be done there. And that's important, because 50 to 60% of what a cow eats is produced on the farm. It's quite heterogeneous, so you don't actually know whether it's the good stuff from the field when the sun was shining, or whether it's the maize silage. You have all sorts of different issues in there. So there's still a lot of development areas in there. And then what's going to become even more important, and I have seen 1 or 2 systems on the market where you want to measure the nitrogen, phosphate and potash in farm-based fertilizer, aka farmyard manure, slurry, whatever you want to call it, because you want to know how many units of nitrogen you put on your field, whether you want to top it up or whether it's just to help you predict your yield. So those are still areas that anything, if you think about it as a history of physics and chemistry, we've been able to measure temperatures for hundreds of years. We've been able to measure weights for quite a long time, and we've been able to measure weights with strain gauges for 50, 70 years, something like that. But chemistry, and I mean a pH sensor is a chemical sensor, it's still quite rare to find those sorts of measurements. And now we're getting into biological measurements, the lateral flow test being obvious one, measuring something with an antibody. So yeah, the things that have been around a long time are easier to measure, but the things we need to measure are increasingly needed, but we haven't done it yet. And as machines have developed, of course, there's machine management software that's sending data, so that people could be monitoring machines from far away from the manufacturers. You know, they'll ring you up and say, oh, your main bearing on your combine's going. We've got 2 men on their way now to fix it for you. They'll be there tomorrow. And the farmer will not have known about that. That's the power of modern software and machine management. But to be honest, those are the very expensive top-end machines have that, but most machines still haven't got anything like that. And most things like an oil gauge and temperature gauge, that's about as much as you're going to get on most machines. So let's have a quick look at farms. Now, farmers get a lot of good and bad press. I would say that about 20% of UK farms are incredibly well managed and incredibly well capitalized. And I'll give you 2 examples. One would be Dyson Farms. Obviously, he's ploughing the money he's made out of all the wonderful designs he's made and manufactured, and he's big time. But most of those big, well-organized farms come from inheritance. I mean, the biggest one is Grosvenor, who own most of Cheshire, and they have an investment fund, Wheat Sheaf, which invests in agricultural technology. You know, you'll not find better farms in the world than some of these top-end managed farms. But as in any Pareto effect, there's another 80%, which is where the bulk of food is produced, and they're highly variable. You've got some brilliant guys and some, you know, and they might be just brilliant in managing their cows, but terrible about managing their fields, or really good at managing something, but not their staff, and they have problems. So you can't tell from just looking at a farm as to what quality it is. And there's a huge variation in margin between the top and the bottom. Then the other factor which tends to mess things up, and I'm not anti-subsidy, but there are distortions. So you'll see, you go to a lot of farms and they've got loads of big sheds, and you think, why did you put these sheds up? Well, we could get a grant for this, and it was a tax break on that, and you know, so they're not always investing in a way that's suitable for the farm. I mean, you can always use a shed. You know, you can store caravans over the winter, and you can put a few bullocks in there and all the rest of it. So it's always handy to have one, but did you really need it? Does it really make money? Then also supply chain contracts are becoming really important. So for example, the main milk buyer in the UK and across the continent is a farmer cooperative called Arla. And you've got your regular milk price and you've got your Arla Garden price. And the Arla Garden is if you can provide some extra data, and that will give you a couple of pence extra on your milk check. So, you know, it's becoming much more important now for us to be able to record animal health data. A lot of activity in developing lameness detection systems at the moment. I see there's one of the grants this year from Innovate UK is for a different lameness detection system. And also, you know, if you've got biosensors, you can start measuring things. But at the moment, fertility is the main thing that farms fall down on cow management. Cows are actually pretty healthy, but there we go. Crop data, you know, nowadays there's a label from a French supermarket. I only picked a French one because they aren't going to chase me for the copyright on the picture. It's just that you now can say what variety of the crop was. Now, if the farm only grows one variety, that's pretty easy, but you'll often get different varieties for different seasons. So the machines or the pickers have to know what they're picking, and that has to be entered into a data system. Another feature you will get on farms is that the internet connections are very slow, and I'm kind of critical of rural internet, because what happens is there's a demand for fast internet, and it's, you know, the accountants and the solicitors and the guys who've bought themselves a nice big house in the village centre, and they need fast internet. And so that's there at the exchange, but a couple of miles out of town, there's the copper wires running low, the voltages aren't very high, and the internet connection's not very good. So some farmers have had to invest heavily to get a good internet connection. And likewise, providers of 4G, 5G, they're going to go where the market is. So if you're next to a main road, you get good coverage. But if you go a mile away down into the valley, you might not get any signal at all on your phone. So these are some of the issues. And obviously, if shipping data, you need to be in regular contact. Has anybody got any questions as I'm rushing through this? Very quiet. Okay, so let's look at farmers. There's a friend of mine down in South Devon, and if you looked at him, you'd think, oh, he's on a beat-up old tractor, but he's an incredibly successful farmer. He was a very early pioneer of organic farming, and he shipped something like 100,000 cauliflower heads, all grown on that. And he runs a few other little enterprises as well, or his family do. They're very independent-minded, self-reliant, and they might not appear it, but they're technically capable. There's quite a big community of farmers who make their own kit in the digital space. They're very committed to what they do, and they're networked. So if they don't understand something, they'll ring up a friend, and they'll ring up another friend, and they'll get the message. So never underestimate a farmer just because he looks, a bit, drives around a beat-up pickup, drives a 50-year-old tractor. That doesn't mean he doesn't know what he's doing. On farms, you have to differentiate between commodity products, milk, grain, and niche products, which is generally fresh fruit, fresh vegetables, or something niche like buffalo meat or deer or something else. So you either go get a slender margin on a commodity product, or you get very big. And some successful farmers get very big, and they have thousands of cows, and people say, oh yeah, it's farming companies. No, it's just they're very good at managing cows, and they've got big through profit. So the advice to any farm is either go niche and find something that not many other people are doing, which has a high margin. And I'll give you a straight example. Back in the 90s, my late wife and I set up a goat farm at a time when there were virtually no goat farms. And we were getting 42 to 45 pence a litre for our milk, whereas our neighbours with cows were getting 16 pence a litre. Now, we weren't able to produce very much because there weren't very many goats, and steadily we built that up. But that is what you'd call a niche, and so you will find them. Some of them are very profitable. Now, the one thing that is different, especially this is a UK phenomenon particularly, but other countries have similar issues. Seasons are very variable. This year has been weird. We had a wet spring, an incredibly dry May and June, then it went wet again, and then we had an incredibly warm, sunny September. And just because it has worked one year to get your particular machine working, it might never work again. You might go out on the field with your new piece of kit, and the machine doesn't slip, and the soil's nice and soft and moves away from the plant with your hoe, but next year it's mud. Who knows? So testing, and the other thing, of course, about is you've only got a short time window. So, for example, there's some guys, we'll mention them later, they're doing a development for UK farmers of asparagus. You've got about a 6-week season. So you can imagine you built your new robot, you get it out to the field, you're going to be worrying about it, and then it starts working, and then you think, oh, we should have done this, we should have done that. At 6 weeks, you haven't got time to turn it around. And I've had that with cow technologies as well. A lot of cows are managed on quite a tight seasonal basis. So there's sometimes only a short window every year for several years if you're developing new things. One thing that's very noticeable, and all over the world, the average age of farmers is 60 plus. I mean, in Japan, it's something like 70. The Americans seem to have the youngest farmers. They're about 57. I mean, that's, for many people, that's very old. But the other thing you'll notice as well in many British farms is that someone who appears to be in charge in their 40s is still got his dad looking over his shoulder, and he might even not have control of the checkbook. So don't be surprised if you find the real decision maker is someone who doesn't turn up very often and was brought up in the 1950s. But having said that, farmers do adopt new technology when it's really relevant. I mean, the mobile phone was the obvious one. I mean, they weren't slow to adopt that. They're not slow to adopt a new breed of cows that will give them more milk. One of the examples from my history is the big baler. In a space of about 5 years, they almost completely displaced the small hand-lifted bales that we'd had before, and now hand-lifted bales are used by just a few equine producers and people who produce hay for that sort of niche market. Everybody else picks them up with machines and big trailer loads of them rumbling around. So yeah, the technology has to have an immediate benefit to the bottom line. Now, one of the biggest things, and people say, oh, it's because the farmers don't pay very much. Well, they've obviously never seen the pay slips of some of the seasonal fruit pickers, because they're generally earning well above national average wage for a short period of time. There's a chronic shortage of the skilled manual people. I mean, we used to, back in the 50s and 60s, it used to be Portuguese or Italian people would come and pick stuff, and then it became East Europeans when the EU expanded. In 2021, we had 70,000 Ukrainian seasonal workers come here. And of course, as soon as the war started, they were not permitted to leave. And this last year, we've had serious struggle to recruit people. And oh, the government will say stupid things about, oh yeah, you're not paying enough and that. But you know, most farms will try and recruit locally, but they can't keep more than 1 or 2 people out of the numbers that turn up. 1 or 2 days is enough to kill off their enthusiasm for picking fruit. Anyway, so there is a big demand for automated machines for picking fruit and for hoeing in organic vegetables, and that will be, that'll come up in a couple of the things that are coming up. The other thing that you need to be aware of is that many of the operations are done by specialist contractors. So the farmer may not have that many tractors for the amount of land he's got, because for particular jobs, whether it's cutting silage or hedge trimming or some potato harvesting, you'll see whole gangs with like 10 machines. That will be a contractor out there doing several farms in rotation. One thing you need to be aware of is that the sector is rapidly changing, and there's some serious crises developing in agriculture. There's a serious decline in soil health, and it's now presumed and proven in various scientific ones, tests, which I'm sure the chemical companies are very unhappy about and trying to suppress. But agrochemicals cause the microbiome, which is what creates the carbon accessibility and the nitrogen accessibility in soil. The soils are often dying, which is why we're getting a lot more erosion, why the rivers run, red in Devon with soil coming down from the hills, because people haven't been looking after their microbiome. And in the period from 2000 and I was around about 2010 anyway, yes, that's when I started, to 2014, I was coordinating UK's greenhouse gas research projects, and what shocked me was the percentage of the fertilizer that's spread on fields that actually goes off to pollution. Something like only 17% of what's applied to the soil actually gets to the plant or is used by the plant. The rest is washed down the rivers or evaporates as nitrous oxide to the atmosphere, which of course is a greenhouse gas. So we have to be aware that things have got to change. You can talk all you like about zero carbon, but we've got to reduce nitrogen emissions, we've got to reduce methane emissions, which are actually quite strong from some agricultural processes. Another sector to be aware of is that processed food is being recognized as a health risk. And if you go into most supermarkets, there'll be aisles full of processed food, and they'll all be made from things like cereals and palm oil, with a lot of sugar and salt chucked in. And I think the tobacco companies took over in the constant concept of constantly improving the product so that people want to have more of it. It's very difficult to just eat one biscuit out of a packet. They're so lovely, you want to eat the whole lot. And that is part of the problem. It's not just because it's a poison, but because it's so delicious that you eat too much of it. But consumer choices are changing. There's more demand for organic. There's more demand for all sorts of green things, and a lot of it, to be quite honest, is absolutely blatant marketing, full of misused statistics. But never mind. There are changes in what people want to buy. And obviously in Britain, food security is a main concern because we actually import about 40% of our food. And at the same time, government subsidies, thank you, Mr. Gove, are switching to supporting biodiversity, public money for public goods, which is a fine slogan, but it is going to lead to some farmers cutting down on the amount of food they produce. And the subsidy tends to distort markets in all sorts of ways. I mean, and then political decisions, and I don't want to get too political, but we still have not implemented the phytosanitary regulations that were supposed to come in with Brexit. So it's an open market for EU produce coming into UK, but we can't ship them out because that's just the way things are. There's no checks on the quality of produce coming in from the EU because we have to trust the EU regulations are extremely good. Oh, well, anyway, that's enough of that. Okay, so the key effects of those changes are we'll see a lot less agricultural agrochemicals used. So, you know, people who are selling sprayers, they're very rapidly having to swap over to having them intelligent sprayers, so that they only spray exactly where needed. And there'll be more biologicals, which will be slightly different ways of actually dosing the field, and they'll be done in areas. So, for example, you know, you're just going to apply a specific thing to kill a particular bug in one particular area rather than just spray the whole crop, which has been one of the disasters. And the other thing, which is very mysterious to some people, but ploughing is definitely a bad thing. Now, I suspect that what happened was somewhere around about 1880, you're ploughing with a horse or an ox, and you're only ploughing 3 to 4 inches, 100 millimeters into the soil, because your machine, your horse, couldn't pull much more than that. Then tractors came along, and you started, oh, okay, we can plough deeper. It's good, isn't it? We can break up the prairies. And of course, the first 2 or 3 crops are going to be good. But then you find you've actually leached out a lot of nutrients, and then you say, oh, better plough a bit deeper. And we began to get things like plough pan, where the base of the plough was creating a smeared layer which wouldn't let water permeate through. And so you then had to have all sorts of extra machines that went even deeper to rip the plough pan out. That was around about 1980 when I was doing my degree at my master's at Silso. People were working on all sorts of mole ploughs and things like that, which would go deep, and they needed bigger and bigger tractors. And the heavier the tractor, the more likely you are to compress the soil. And so ploughing is definitely now seen as a bad thing, and no till and minimum till come in. And then you have, well, how do you kill the weeds? How do you deal with this? And so there's a whole lot of new technology being developed for exactly these reasons. And of course, the ploughing leads to loss of carbon and nitrogen and pollution. And also, it's very expensive to drive a 700 horsepower machine across a field, dragging a 10-furrow plough. So that's enough of that. Let's talk about engineering. Roundabout, I mean, tractors have been around since about the 1920s, but the sort of what you'd recognize as a modern tractor certainly appeared around about the 1940s. This would be a TE20 down here, which is Harry Ferguson's tractor, very famous one. You still see them at rallies and all sorts of things. And basically it's a mechanical horse, but with a couple of extra features. Harry Ferguson's big invention was live linkage hydraulics, which would actually, with a bit of regulatory, it would lift the plough out of the ground when the tractor started slowing down and things like that. And it had rotary power, which allowed you to drive secondary machines. They were mostly 2-wheel drive. 4-wheel drive only really became popular in about the 70s and 80s, and is now even small cheap tractors are 4-wheel drive. The machine, actually, I think it cost about £500, which is £18,000 in today's prices. But now, moving on, however many 70 odd years, you can now buy a manufactured in India, but not rubbish at all. It's a Yanmar company. It's all built very well, costing almost half what they used to, but with a lot more things. Tractors were dangerous things, so they have to put cages and cabs on them. You've still got rotary power, but you've now got 2 hydraulic outputs up the back to provide pressurized oil to drive machines. You've got 4-wheel drive as standard. You've got mid-mounting points for implements. You've got front mounting points for implements. You've got power steering, and from my point of view, hydrostatic transmission. Great. We just need to switch some valves to make the thing go faster and slower. No one said a word. I'm quite happy to continue. So the tractor will do more than one thing. Right, so there's your traditional, well, it's actually not traditional, it's a reversible 6-furrow plough, but you need a big machine to pull one of those. But it's just basically dumb metal, that's all it is. Oh, then you've got rotary power, front and back here. These are a set of mowers, so you can, and these mowers, you'll be driving across this field at 15, 20 miles an hour. These are high-speed machines, and that in itself brings an issue for autonomy. Oops. Then you're getting into more intelligent machines that have data. This is a seeder. Now, somewhere on top of this tractor, I took this picture, and it's got a satellite navigation. So there's 2 redundant things, which you might think, oh, that's an antenna. No, it's actually just a dumb disc which we folded down onto the soil, so that in the previous generation of technology, you just follow the track of that you've just driven by having one of these flip out and create a little furrow for you to follow. But this machine is a pneumatic seeder, so that needs to be driven of itself, but it also needs to know where it is, so that your sowing is exactly matched to what you want to do in that field. And you can't neglect the fact that a tractor also is a massive producer of hydraulic power, and so there's all sorts of things you can put on the back of tractors, like diggers like this one, or hedge trimmers or whatever. So it's a very versatile machine, and it's a mistake to think, oh, all we need is a robot. So let's have a look at some of the other things. Right, so let's talk about the tractor now as a digital machine. And this has been creeping in gently over years. I think the big revelation was in '93 in the first Gulf War, when American tank commanders were buying GPS systems so that they could precisely locate themselves and call in airstrikes to exactly where the Air Force could find them. Well, not find them, but find the other guys. And that in tractors has led to auto steer. So you just set the thing to drive down a straight line that's coming from your precision location system, and more sophisticatedly now at the end of the road the machine will actually say, okay, I've got to the end of the headland, and we'll just do a turn and we'll come back down exactly in the correct line on the next set of passes. But as you then get into other devices, you get into a thing we call the isobus, which is ultimately a CAN bus, but for agriculture. And that now has a feature called tractor implement control. So let's say that seeder box that we were looking at, that says, oh, I'm sowing this particular seed, and the guide wheels need to turn at 3 meters a second or whatever some number is. So it then controls the speed of the tractor. And then if it gets a certain amount of resistance from the blade, it might change that. So it's actually got a control unit, which is actually determining how fast the tractor moves. The tractor's still going down the straight line that it's been given. The driver has to do very little except monitor what's going on. So you'd have to ask that question. I think the digital tractor is almost an autonomous machine. It's being driven by sensors. So there's a concept we call PNT, and I was recently called into a committee meeting to discuss position, navigation and timing. And of course, they're all tied up together, but this is a critical feature in agriculture. I mean, this started off as a government thing. The satellites were up there and they began to realize you could do stuff with the images. And in fact, my son-in-law worked for the EU research department, and they were mapping olive groves in the south of Italy because there was a massive scam going on claiming, you know, hundreds of hectares of olive oil should be supported by the EU, and the mafia was in there. But you only needed to be a couple of meters out. You know, it was good enough to be for some farm inspector to drive and say, hold on a minute, this is, yeah. And then at the same time, they began to introduce what was called set aside, so that in the UK, the farmers would have to grow a strip down the side of the field, which was set aside to let the wildlife grow and not grow crops, because we had too much cereal in the early 80s. So 2 meters was good enough. And then the infrastructure guys, they need about 1 meter, because if they're going to go and find where the manhole is, you know, and it's under the long grass, but 1 meter is good enough. Same with poles. You know, you can actually find the pole because you can see it in the middle of the field, but you want to have a map where it is. So that precision was good enough. But once you start getting to treating particular zone of soil or a plant or a particular, you want some resolution round about the width of a spray nozzle. So you're talking 10 centimeters. But in the past few years, we've gone right down to inaccuracy, down to something like, gone up in accuracy, I suppose you'd say. It's got to be within 1.5 centimeters now for the location of the implement on the back of the tractor. And you can see how things have changed in that you can buy an auto steering kit, which is the full connection to the satellite with an RTK, which is the real-time kinetic base station, which adjusts your local what the tractor's measuring against what's known to be a slight offset for the particular zone, due to distortion of the signal coming down from the satellites, etc. Weather can change it a bit, and so on. So so you can get a complete kit for under £4,000 just about now. I mean, the better ones are a little bit more than that, but it's better. Who says it's better? Does it work? But there's a farmer in Canada, Brian, I've forgotten his second name, but they call him Brian T. Farmer Brian T. He's developed Open Ag GPS, and if you start looking stuff up on YouTube, plenty of farmers saying, "Oh, I built my own kit for under £1,000. You just buy this box, you buy that box, you do a bit of hacking, and you're up and running." So this is when I say farmers can be very techie minded, and of course the farmer down the road doesn't want to spend 4,000. He can get his mate down the road to do it, knock it together for much less. So be aware, there's always a way around the big company control. I'll briefly mention drones. You know, whenever the media come up with digital agriculture, they always talk about drones, but actually they have a relatively low potential. They're very good for mapping a disease in a crop and the crop status. There's no soil compaction. You don't have to drive across the field in a tractor to measure anything, and they're much faster. You can do a field survey in a half an hour, whereas it would have taken several hours to drive back and forth across it with a fixed rig. And there are machines with enough payload that you can do some spraying. And I've even seen that some guys have started sowing under a cover crop, so that when they cut the main crop, there's a cover over the soil, which is a key part of organic farming. But it is a regulated process. Civil Aviation Authority takes a dim view of these things flying in controlled airspace, and so it's usually done by contractors who have to have a license and all the other paraphernalia. So yeah, that's not really a farm thing, it's a contractor job. So let's talk a bit more about digital attachments and tractors. Most of the implements are still dumb, but some have digital recording. So for example, balers, they count the number of bales. And if a lot of baling is done by contractors, and they will charge you by the number of bales. There is a little click counter on the side of the machine, but obviously it's much easier if you can feed that through into a database straight away, and also have the location. Amount of slurry being discharged by your tanker, which can be highly variable. Things like the nutrient density of the slurry discharge needs to be done. That's all. You can buy kits like that, I should say. And some have onboard processing. So we've talked briefly about that, but let's talk a bit more.
So did you want questions during or after?
Well, yeah, you can stop me and ask one, because I'm beginning to wonder if there's anybody there. To be quite
Well,
honest.
that was what I was thinking. So going back to your previous slide, I was just wondering, presumably, is the Internet of Things relevant to these digital attachments?
Well, it is. They are absolutely the Internet of Things, provided
Yes.
they have an internet connection. They don't all have that, of course. Very
Yes.
often the data is stored on a USB stick, and the farmer puts it in his pocket and forgets about it. So, but yes, I mean, ultimately, it's the Internet of Things.
Okay.
So things like digital recording of stuff. I was just about to come on to that, actually, because this is the next slide. if that's any help. But yes, this is Internet of Things, no doubt about it.
Right. Thank you.
So because there's a few major tractor manufacturers, I think they call them the big five, although there are quite a few smaller ones as well, specialist vehicles. There's a lot of implement makers, and the implement makers have specialist markets. So the industry's got together. So the Agricultural Electronics Foundation, which is a company run in Germany, and they have developed standards. They're not legal standards, but they're industry standards for connecting machines together. And ultimately, that is your Internet of Things, because you have tagged data files which will tell you what was done, when, where, and so on. So yes, these machines are internet connected, but that's not a legal requirement, but it is happening. So you've got electronic control unit for the tractor. You might have some nodes where it's feeding data in, like oil temperature or whatever. You've got a connector there, physical connector and a breakaway connector, and the AEF do specify those. They try to get people to use high quality ones. On board most tractors now, you'll see two terminals. One is the virtual terminal, which is telling the tractor guy what's going on, but there's also input screens as well, so he can change the task that's being done, for example. And then each of these electronic implements, this is a seed box by the look of the drawing. You've got a bus inside with an electronic control unit, because for example, across this machine you might have a dozen seed boxes all releasing seeds, and they'll all be in electronic contact with the ECU. So that's the isobus. It's a voluntary thing. There's a stack, obviously, where you've got your application on top, and you've got these various standards. There's a I can put that in the chat if that's anybody wants to have that contact. That's just a company that is very good at selling itself as being an isobus supplier. But you've got the standards here, and you've got down to the CAN network, which, if you're familiar with vehicle CAN bus, the actual physical protocol is quite similar, but there are some agricultural extra features. So now we're getting on to seriously smart implements. This is a machine called a RoboCrop, which is a hoeing machine for organic vegetable production. And it's been developed by actually a couple of old friends of mine from Silso, and they sold the concept to Garford. So you can buy a RoboCrop from Garford. What this machine consists of is a camera system, and down here you can see some of the type of camera images. So it has a library, which obviously would have to be downloaded from the internet at some stage, of what, let's say this is lettuce at a guess, what it's going to look like, and what it's going to look like at so many weeks post sowing, because that will change. And then what's not a crop is to be hoed out. So there's a little set of blades here which swing round. This is so there's also obviously hoes for what we'd call inter-row hoeing, but this is actually intra-row. It's actually going through and cutting through the weeds between each one of these lettuce plants. So there's a lot of processing going on here. You've got a camera here, a camera there, so there's 6 cameras across here. You've got to take a decision. and swing that blade at the right time. So that's what I call a smart machine. Now, it also needs to follow a previous sowing machine, sowing as in sowing a seed, not sowing a piece of dress or something. So you've got to have an exact location for your seeds, and the machine can then use that plus the algorithm that says that's a cabbage, that's a lettuce, that's not one of ours, look, different one, I'll chop that one. So you've got all those things going on simultaneously. Now that is pretty sophisticated, but to be fair, Nick Tillett and God, I forgot his name. Sorry, he'll come back to me in a second. They invented that. Tony Haig, Nick Tillett and Tony Haig invented that back in the 90s when we were all at Silso then, and they've managed to go on and turn it into a product, which is great work. But that actually is relatively simple in the sense that you know roughly where the tractor is, you know roughly where these, and you could probably do a reasonable job just on dead reckoning. So we're on to the next level now, which is robot laser weeders. Now, some crops aren't sown in straight lines, they're broadcast, as we call it. You know, you sow the field on scatter. That's what they're doing here with rocket. So they grow rocket more like you grow grass, and then you cut it with a mower in effect. So this machine is shining LED lights that are particular wavelengths of the particular crop that you're growing. So it can recognize what's a rocket plant and what's not a rocket plant. So that's the recognition system. But then to kill the weed, they then have a targeted laser which shines down and gives it a blast. And you think the military's got technology. Hey, this is farming. So yeah, when the military starts shooting down missiles with lasers, you'll know, well, they copied it off a farm. But these machines, I have to admit, I've seen these machines working. There's a hell of a lot of noise because they're running a couple of diesel generators to run all the servers that have to scan across maybe 4 meters, identifying all the plants, powering the lasers, zapping, and so on. So they move across the field at a slow walking pace, but no one wants to hand weed rocket. And weeds grow, they don't care what you're sowing, the weeds will be coming. So this is quite an interesting new development. There's a couple of companies. This is Carbon Robotics. There's another one called Helix. Oh, so yeah, so you want to join those intelligent machines together. So AEF organise what's called a plug fest, where they get everybody, tractor manufacturers, implement manufacturers, and it costs about €3,000 to be a member of AEF. So it's not a sort of thing you do as a startup on the first week, but very quickly you need to be getting, and you can just buy the spec anyway. You don't have to go to one of these things to understand the plugs. But if you've got something new, and there will be lots of new stuff coming through, then you'll need to go to one of these and tell them, oh, our data is formatted this way, and we have to do it that way because the only server that will run this technology is, and so on, that type of thing. So yeah, there's a couple of these a year in Europe, and I think there's one in the States every year as well. So let's move on to what people call autonomous tractors. Any questions? I've been going nearly an hour, I think. Don't let me overrun, please. There's no current legal restriction in fields, so no one will tell you you can't do that there here as long as it's on private land. But you still need to get the machine to the field, so they're not road legal, and most of them have no driving. So mostly they're saying, okay, guys, you're going to have to load it on a low loader, drive it to the field, fuel it up, fire it off, and off it goes, and then come back and collect it later. That's fine, but it's not that clever, is it? They're quite low powered mostly, but they're quite heavy. So they're not actually solving the soil compaction problem, or not many of them. But I have to say that I started getting interested in this about 3 years ago during the pandemic when I sold my companies. And there were about, I could count them on the number on 2 hands, the number that you could see has been in development. Now there's probably 200 or 300 all over the world being developed. And there's loads of company startup. Most of them are dedicated to a single task, which to me isn't really robotic. And they're very often unstable small companies. And sometimes you can see the company's just been set up to get an idea, get some money into it, and then sell it to John Deere or AGCO for a huge amount of money. I mean, their model there would be a company called Blue River Technology, which was bought by John Deere for about $200 million a couple of years ago. And the major companies, the big tractor manufacturers, also are working hard on autonomous tractors because they can see this is coming. But let's have a quick scan through a few of these that you'll see. I mean, if you start searching online, you will find dozens of them. This is the small robot company in the UK, which mostly is a monitoring robot with some spray capability. And it's just, they're trying to go for what you might call small, low-cost systems, which will just do the job in a field. Even more niche is Muddy Machines, which is a UK company. I saw them in California last year, and basically it's an asparagus picking robot. Last year they said they were going to have 250 out on farms this year. Actually, I don't think they managed to hit that target, but there you go. That's the problems of startups, and I'm not quite sure why they're showing it in a stubble field, not in an asparagus field, but there we go. Now this one's an interesting one, and I'm sure someone will ask about power at some point. This is a massive solar panel, and this is a solar-powered tricycle robot, which just does sowing and hoeing. They use GNSS location and dead reckoning. They know where the seed's been sown, and so they go back and hoe around it plus or minus a couple of centimeters. They don't have an image recognition feature like the RoboCrop. So if it's the wrong thing, they'll just hoe it out. If the plant has moved, let's face it, plants don't always stay exactly where you sow them. There's a mid-mounted toolbar, nothing on the back, nothing on the front. Interesting, I saw one of these at the Llama show this year actually, in February. And I asked him what the wet rain gauge was on the side. He said, well, if it starts raining, the plants are going to start moving around in the rain. And so we stop the machine when it detects rain. So there you go. That's an interesting interrupt to develop. This is one of my favorite companies in this sector. They've got about 300 to 400 machines out in the field. It's a French company. Most of their stuff is for viticulture, but this also shows you what a robot is, the basics of a robot here. You've got a wheel at each corner. You've got a frame that links the two axles and a place to hold the heavyweight engine. This is a diesel engine. You've obviously got an RTK dish, and you've got a whole array of sensors. But this one I like is they've got a front attachment, a midpoint, and a rear, so you can use it to do 2 or 3 jobs at the same time. And that's about it. It turns in its own length. A lot of these guys have gone for individual wheel control, and that's I like them, and it looks pretty cool to me. This is a very practical Australian robot, and they've got quite a lot of these. It's a farmer-developed company in Queensland, and they just put these huge wide spray booms and other things on them. I did ask him, how do you get them to the field? He said, our farmers don't have to go on public roads. The farms are big enough that it's all internal roads. So it's basically a diesel engine, a frame, 4 wheels, and a computer. Internet of Things. And not to leave out the big boys, this is Case New Holland launching their system. I still think they're wedded to the big tractor concept. And you can see that all they've done is taken a cab off and put a computer in place of a human. And because a lot of their market is the wide open spaces of North America and Australia, they will still probably be promoting heavyweight machines, but I'm not convinced that's the future. I think the future is smaller, more multiple machines doing different things in the same field. And the carbon robotics laser weeder comes either as a thing you can put on the back of a big tractor, admittedly, or it comes as self-propelled. And I was talking in California, these guys were saying, well, they think it's the actual investors think it has to be an autonomous robot, whereas actually, as long once they get the thing stabilized, it's just another tool you put on the back of a tractor, which has already cost you £100,000. Why would you pay for someone to build another front end tractor just to drive this thing around? And that will be the logic of many farmers, is that I've already got a tractor which will do 10 things. Why do I want a machine that's going to cost $500,000 and only do one thing? So we'll see how that pans out. But I still think the tractor has a huge future, but as a autonomous style vehicle. Here's a little breakdown of laser weeding. So yeah, you illuminate the plant with the LEDs, you identify it, and then you can either zap it with a laser or you could use a nozzle spray just to hit the one plant at a time. And it just keeps moving. So let's come on to some of the practical issues where you've actually got these. The point I'd make out is these are very complex machines we're getting into. You've got navigation, you've got obviously machine control, you've got software trying to identify plants, you've got controls of lasers. So there's a lot of things that could go wrong. They tend to be quite a niche machine. So there's only so many people who produce asparagus in the UK, maybe 50. So if you're selling an asparagus picking robot, you haven't got a big market, and the nearest place you go and find someone else to do it would be in, you know, somewhere in a particular area of France, because these crops tend to be grown around the marketing distribution channels that are there and the particular soil types that grow a particular crop. So be aware of that. You know, this might be a long way to the next group of farms who'd have one of these specialist machines. You know, Rocket, again, very much a North Italy type product. You've got software interfaces which go via physical plugs. Now, in my experience, if you're going to have an issue, oh, my machine's not working, what is it? You're going to end up having to go around and test the physical plugs, because sooner or later you'll find someone's trodden on one while they're climbing over the machine, or, you know, it's been hit or something, or a piece of bird shit has landed on it. You've got all sorts of things that can go wrong with physical plugs. And unless, if you turn up on a farm and the machine's not working, you know, you'll slowly find that the machine's probably not being used in the way that it was intended. You know, anyway, these things happen. You've also got software interfaces via an unreliable internet, and that has to be dealt with, which it could be just it hadn't received the right data file, so it's using the old one. There's all sorts of little things that would need to be done on debugging and maintenance. It is a harsh working environment. When I was working for Silso, we used to have all these salesmen who would come in and say, oh, this is a military tested piece of electronics, blah, 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 blah. You think, yeah, but it's going to break within 3 weeks because the guy's carrying it. It's not going to be too worried about it. Whereas a farmer wants it to be running for 10 years. And the same for North Sea. Whenever they say it's North Sea rated, so that's not the same as a farm, because we have biological degradation as well as chemical degradation. And at the moment, I'd say that most agricultural dealerships were trained as mechanical engineers. They're not absolutely confident about, you know, plugging in. I mean, obviously in the motor trade, they've got used to plugging in scanning systems and using that as a diagnostic. But in agriculture, that's still quite a new thing. And at the moment, most digital training goes into degree level courses in agriculture or agricultural engineering. So these aren't going to be always the people who are going to want to crawl over a tractor or get on top of a dirty robot milker, which might be covered in bird shit on top, and deal with all the software issues that will come through, you know, things just not being where they're supposed to be. So I'm getting towards summarizing now, and we've come a long way in 70 years. You know, we come from basically what was a mechanical horse that would pull something to digitally capable robots. But do we actually need autonomy in tractors? I'm not sure. I think they're given a task, and when they've done it, they're switched off, and then they do something else. That's not autonomy in my mind. In autonomy, in my mind, the tractor would be standing outside saying, hey, it's time, my sensors have picked up that it's time to go and sow some wheat, and you know, and has already loaded itself up with its automated system. That to me would be an autonomous farm where the machines decide what they're going to do and get on and do it. We're a very, very long way from that. And then what about the humans? And I've seen some videos which scare me to death of machines doing 15, 20 miles an hour across a field under autonomous control and saying, oh, we've got a stop button on the side. Yeah, right. So if it's running faster than Usain Bolt, who's going to manage to be able to control that machine? So you have to have some sort of off machine control. Most of them do have that, but if there's only one person with a controller, and the other humans that we have might not be people who know anything about robots. They might be rogue campers that just decided to crash the night in the field and they're lying there in the grass at the end of the field. Yeah, and we have to be able to cope with those things, quite apart from farm animals, dogs, wild animals, and so on. We need to be able to not crash into things. And then we also have to decide who's actually in charge and who's liable. You know, if the machine crashes into a farm building because the sensors won't work, is it the tractor manufacturer? Or is it the guy whose implement said, go faster, I need more seed, or something like that? Or is it the legislators who can't be asked to actually get on and do any government at the moment? Then we've got the issue of who owns the data and who owns the machine, and have you got a right to repair it when it breaks down? Have you a right to get into the software and hack it? Because farmers will do that. And we've already run into serious issues in the States because John Deere said, no, if you don't pay the software license, the machine switches off, and that's that. So people then jumped up and down and said, that's the whole concept. You bought my tractor. Why should anybody else be able to stop you using it? So already, and this is very hot news, there's 4 US states now in 2023 that have just enacted a right to repair, which basically means the right to get into the software, whether it's by an independent contractor or the farmer himself. So there's already 4 states, and it's specifically for farm machinery. So that's quite an interesting thing. I don't know what our government's up to, but I think they're probably more interested in protecting Taylor Swift's digital rights than worrying about tractors. So a little bit of politics there, but hey. Now, you asked about Internet of Things. This is one of the latest things from John Deere this year, is that up until now, you've used a USB stick to go around and set all the machines to be on the same page. They're now into what their latest piece of software is called Data Sync, which, so let's say you've got, here we got 3 pea binding machines working in the east of Scotland this summer, and all synced together through this new Data Sync software, which will tell them what each machine is doing, where it is at any given time, so that at least they'll avoid colliding with each other. And mostly they're actually just recording the amount of peas they got on board and calling up the trucks to take it away. But that's where we're going with this, is total sync and integration. And I think I've overrun a little bit, but I'm still ready to take questions. But thank you very much for listening.
So very, very quickly, for me, that's part of the key to the thing. These things have to be community aware, and they have to be interlinked, and they have to know what else is around them, what it's doing, where it's going, why, if it suddenly makes a sudden movement, what it's got to do and how that impacts the rest of the community around them. And that isn't just the autonomous vehicles, but that's being aware of the people that are around them as well, and the animals that are around them. So that Internet of Things and that social awareness and that community awareness is where your great autonomy will come from. And that's where the big innovation needs to be, in my opinion.
Well, I'm glad you say that, because I'm going to move to the last slide, because this is a project I start next week, which Innovate UK have agreed to fund, which is, I call it the safe hybrid working, because it's as much about the people as it is about the machine. And my example is loading cabbages is hard work. You're walking in mud, you're carrying 10, 20 kilograms. You don't want to go more than 2 or 3 steps. So why don't we have voice control on the machine? Why can't we just make it move where we want it, when we want it? And not just me, but 2 or 3 other guys are also loading cabbages. So that's my project for the next year, is to try and get and just show that you can convert an ordinary tractor to voice control. After all, you can do all sorts of clever stuff with remote control. But like you say, it needs community awareness, not just the machine, but the humans. I mean, do we have to have signs up in the fields that says, beware, robot working, stand well clear? Or do you just have the machine say, hold on a minute, there's a human in front, I'm going to slow down and I'm now going to stop because I'm within 5 meters of them. And then let the human decide what they're going to do next. But a stop button on the side by the wheel is not a good thing. I just don't think that's sensible. So I'll just slip back tonight. There you go.
You've got a hand up from Martin who wants to ask the question by the look of it.
Sure.
Yes, so you're covering the safety aspects to do with people not being mown down when they're walking in front of something or animals. I was just wondering about the employment aspects. Obviously, with other walks of life, we're concerned now. Will technology put us all out of work, or will it mean that we're freed up to do other things? So I was just wondering how that works in this question of farm automation, whether people, the extent to which these newer machines will replace people on farms, or whether people will still be needed to do other tasks.
Well, I think this is the dilemma. I mean, just from the defensive side of the agriculture industry is we can't recruit enough people. We can't, and we've heard that all, like there was a shortage of herdsmen. That's why we invented robot milking. It was seen as this is an existential threat for the UK dairy industry. No one wants to milk cows. Then, of course, we ended up with 20,000 Poles coming and milking cows for a few years, but they've gone home now. We still need people to milk cows. So there's always been a shortage of people, and particularly what you call skilled manual, picking fruit, lifting cabbages. There's a lot of RSI. People don't really want to do it, and people are not desperate enough that they will do it just because they need the money. And some of these areas that have had really anti-immigrant, they're taking all our jobs. When the Poles disappeared and went home, and the farmers were saying, well, come and pick our crops. Oh no, I don't want to do that. Why can't you get someone else to do that? But I'd also say these technologies create new, much more interesting jobs. Well, interesting for people who want to get inside a computer and so on. If you think of the skills required to service a robot milker or to service a robot, there's still going to be plenty of engineering jobs, and there'll always be other jobs that people can do. But having said that, if I put my landowning hat on, I advertise to say I've got some allotments to rent, and I get people coming up and they're happy to do hard agricultural work growing their own veg, and they're not going to save much money. It's fresh vegetables aren't very expensive for the wrong reasons. But that's the nature of it. There's very low margins in agriculture, and quite a lot of labour required still.
Okay, so right, Toby, I've got in the chat here from Claire, and she asks, how does agritech move forward in terms of new ideas? Is it always farmers led, and how does feedback from those on the ground work? Is there a meeting space for tech inclined farmers and techies interested in farming, or is it quite informal?
Well, it's all of those things. There are a lot of forums of there's AgriTech-E, and there's the various agritech. If you start searching online, you'll find too many places where you can join a forum, and then you find it's sort of like been dead a year or two. But these things do spring up. Nothing is organized in this country. Other countries have got more formal structures to pull people together to do it. And not just, if you go to California, they're very Californian focused, and there are organizations, and the colleges there have to be much more responsive to what the farmers are talking about. Yeah, but farmers are good at inventing stuff, but other people are too. I'm not a farmer. My dad was a builder, and my we didn't have any land. I just went into it because I just like milking cows. No, actually, I like the money I got from milking cows, I should say. And it took me several years as an engineer before I actually made more than I made as a herdsman. So the idea that agriculture is underpaid is also one of those little myths, which is quite comforting for people to understand what's happening.
Well, thank you for that, Toby. I found it quite interesting, even from my long years of escaping from the farm. So yes, that was really quite interesting. I thank you. I thank those of you who have attended as well.